My name is Muhammad Amirul Ahmad Benjuari. I will explain for our digital fan speed simulation, which is for task 2. First, we choose hardware. Okay, firstly, we click the button 1 interrupt. Okay, after that, we switch on the button 0. The 7 segment speed will show no speed, and the LED will not moving or blinking, which indicate uh, the fan speed right now is not moving. After that, we switch on button 1. Okay, right now the 7 segment display will show speed 1, and the LED will moving from the right to the left in a lower speed, which indicate the fan speed right now is moving slowly. After that, we switch on button 2. The 7 segment display will show speed 2, and the LED will moving from the right to the left in more faster speed than speed 1. And then we switch on button 3. The 7 segment display will show speed 3. And right now the LED is moving from the right to the left in more faster speed, which indicate the fan speed right now is moving more faster than speed 2 or speed 1. And lastly, we switch on the button 4. The 7 segment display will display or show stop, and the LED will blinking, which indicate right now the fan speed is not moving. Okay, that's all from our group. Thank you.
This is Yuen here, and I will be presenting the programming for the first part for task number 2, which is digital fan speed. So first of all, what we must do is declare the hardware modules used in the program and bind it to the memory. So as we can see here, we have using switches, LED, as well as 8 7 segment LEDs. So we will put each to the memory location. After we have done that, we will be using at origin $1000. We will set the initial condition for each hardware module used. So the LED will be stored at D0, switch 1 will be D1, switch 2 at D2, switch 3 at D3, switch 4 at D5, and switch 5 at D5. So after we have defined the hardware module used and also we have written down the initial condition, we can move to the main part of the programming. So for that, first of all, we will need to move the D0 to LED as stated above. And so for this program, we need to subtract the source operand from the destination data register and set the condition codes according to the result. So after the subtraction, if the value obtained is high, we will jump to startup subroutine. Startup subroutine in this program is over here. So the same thing will happen to switch at D2. We will subtract the source operand from the destination data register and set the condition codes. Then if the value obtained is high, it will jump to speed number 1 subroutine, which will be in the bottom over here. So the same can be said for switch at D3 and switch at D4. At switch at D5, when the subtracted value is high, it will jump to the stop subroutine. And finally, as the ending for the main programming part, it will be branched back to main. So it will make a loop. So that is all from the first part of the programming. Thank you.
Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Nima Syahban Muslimin and the memory is B01201042. This video I want to explain about my task programming. As we can see the startup for this programming, we can see the move.b can display on this coding. We can see hashtag hashtag $37 SEG1 display on end, and move B hashtag $SF SEG to display of 0, and other move dot B, we can see a description of this startup. And for the speed 1, ROL dot B, hashtag 1 comma D0, that's rotate operate to the left, and move dot B DO LED, BSR fast branch to fast the subroutine of speed 1, move dot B, hashtag $00 SG1 to no display, and other description this for move dot B we can see for the speed 1. And for the speed 2, the coding start with ROL.B, hashtag 1, D0, rotate operate to the left, same as the speed 1. But for the PSR, we change fast to the faster, for branch to faster subroutine. Then the move.b is the same as for speed 1 coding, but we need to change uh, a little coding such as move.b hashtag as $5e with the the move.b hashtag $s30 sg7, we change to $s5b sg7. Okay, next for the speed 3, we start with ROLB hashtag 1 D0, rotate operate to the left, but we change from the speed 2 faster, we change with the fastest, where the speed fan with the very fast for the speed 2. For this coding is the same as the speed 1 and speed 2, but we change from there. Move the B HTS for 4F SEG7, same as the speed 1 and speed 2, change this coding. And the last coding we can see start move.b as hashtag as FFD0, move.b D0 LED, PSR speed 0, branch to speed 0. That's mean the switch we when we press is display as stop. That's mean digital fan speed will stop processing. Uh, that's the program from the switch programming. That's all for me. Thank you.
Hello, my name is Muhammad Rehan bin Azwan. My matrix numbers is B012010136, and I want to explain for the task 2 coding for part 3. For speed 0, the command is move.l is to determine the program speed and higher number equal lower speed. For the BNE is to branch to wait 0 if not equal 0. For the RTS is to return to subroutine. And next, for the fast, the command is move.l is to determine the program speed higher number equal lower speed. For the BNE is still the same, to branch to wait 1 if not equal to 0. For the RTS is to return to subroutine. Next, for the faster, the command is move.l is to determine the program speed, the higher number equal lower speed. For the BNE, to branch to wait 2 if not equal to 0. For the RTS is return to subroutines. For the fastest, the command is move.l To determine the program speed, the higher number equal lower speed. For BNE is to branch to wait 3 if not equal 0. For the RTS is return to subroutine. And the last one is ends $1000. That's all for me. Thank you.